Okay, so already we have finished most of the part of the first A. ठीक है. Now let's talk about the one or two topic which is left. ठीक है, that is the conductivity and all. So already बताया था conductivity क्या होती है ना? So it's a reciprocal of resistivity. Okay, it's a reciprocal of resistivity. Like we have resistivity is been denoted by rho. Okay, so conductivity has been denoted by sigma. So it becomes sigma is equals to 1 upon rho. Okay, that means sigma is inversely proportional to rho. Okay, or you can say rho. Sorry, I have written same word,
Hmm.
sigma. Okay, and or we can say sigma is inversely proportional to rho. Okay, because one is the conductivity and another is the resistivity. One will stop the flow of electron, one will allow the flow of electron. Okay, so for conductors what should be required more, conductivity or resistivity?
High conductivity.
Yes, what is required more, conductivity or resistivity?
Conductivity.
Conductivity, yes, definitely conductivity. The more the conductivity, the more good conductor it is, or more amount of the current it will pass through it. Okay, so now as we have learned about the unit for resistivity, a unit of rho is ohm meter. Okay, so the SI unit of mute kar lu bhai is, that is conductivity, is what it will be? It will be ohm inverse and meter inverse. Okay, which can also be written as, there are many things which you can write. Okay, which will be also written as ohm inverse, meter inverse, or you can write this as a inverse like this, or you can write the taking the name of, that is Simon meter inverse. Okay, so you can use any of them, but mostly you can write this one and this one. Got it, everyone? Is it clear?
Yes, sir. Yes, sir.
Okay, and this sigma the symbol is called sigma. It's a reciprocal of specific resistance, or we can say conductivity, resistivity, reciprocal of resistivity, or we can say specific resistance, specific resistance. Clear है
Yes,
everyone?
sir.
ठीक है. Now
So specific resistance is also for
resistivity, yes,
both are
specific.
same.
हाँ, specific resistance is only called the resistivity. ठीक है. Now
Okay, sir.
how will you choose the material? Okay, now suppose if you want to make a wire, okay, for the conductor, for connecting it, so how will you choose that? So there's a topic, that is material, choose for material of wire, we can say. Okay, we can write choice of material of a wire. So there are 2 or 3 points which you need to keep in your mind while taking the material of a wire for the circuit of a conductivity. Okay, so now the first one is the wire used for electrical connection and for power transmission. Okay, now what is this? It's saying there's the wire has been used for electrical connection. Okay, for electrical connection means if you want to just transfer some amount of electrical energy from one point to the another, like if you have a battery here, okay, and you just need to pass it from this resistance, So this wire is being required now for doing it. Yes or no?
Yes, sir.
है ना? So for that and for power transmission means like the current which is being coming from the power plants to the homes. Okay, so for this also, so what is the first thing which is being required? They should have, the wire should have, the wire should possess negligible resistance. That means if the resistance is very less, then it will be very good for that wire. ठीक है?
Yes, sir.
Getting everyone? Because if the wire
Yes.
resistance is negligible, then what will happen? Then
Current will
current,
flow easily.
current remain unaffected. Okay, current remain unaffected,
Unaffected.
and loss of energy due to heat is also low. ठीक है? That will also low. So that's why we have the material, like, see, now silver is a good conductor, but the thing is it's a material which is costly and used for making the ornaments. Okay, similarly gold also, but the thing is we cannot use them na, we cannot use them. So what we do here, we take the material such as which is feasible. Okay, so example, we take copper, that is Cu, aluminium, Al. Okay, these are the widely one. So when you go to the market, it becomes like, when you just see for the AC and for all, so the compressor have the winding, so fan has the winding in it. So some of the fan comes cheap and some of the fans are costly, like when you go for O general ACs, so in that the compressor have the copper, the windings, or the, okay, the filament inside the compressor, it's of copper. But when you take from the some very local or from some like this one only type of ACs, so it has the aluminium one casing. Okay, so that's the difference, because copper is much better than the aluminium, but it is costly, but it is costly. Okay,
Yes, sir.
clear?
Yes, sir.
Now if we take these types of wire, then what we got? We get we get less specific resistance, first of all. And second thing is, we need thick wire. Why thick wire? Thick wire means area of cross section increases. Okay, due to which its resistance decreases. Getting my point?
Yes, sir.
Okay, resistance decreases. So if we take the thick wire, okay, and we get the less specific resistance also, thick wire also we are getting it, so we get the very less amount of resistance in it. Getting my point?
Yes, sir. Yes, sir.
So out of these material, which is having very less specific resistance?
Copper.
देखो ऑप्शन दे रहा हूं मैं, very less specific resistance, arrange them in increasing order. Okay, yeah, just wait a second, let's frame like this. Arrange the materials in in increasing order of their specific resistance. Material given: aluminium, copper, silver, iron. Yes, do it everyone, fast. जल्दी से गिव इट इन द चैट बॉक्स, जल्दी से, स्पीड में, डोंट टेक टाइम. टाइम लगाओगे तो तुम्हारा गड़बड़ है. You won't be able to do the revision for the work and energy. Do it fast. I have asked for increasing order of specific resistance. Navda. Ashita correct. नवदा गलत है, उल्टा लगा दिया, क्वेश्चन गलत पढ़ा. नवदा.
Yes, sir.
आवाज नहीं आ रही है, क्वेश्चन गलत पढ़ लिया ना, यही पेपर में होता है. इंक्रीजिंग ऑर्डर ऑफ स्पेसिफिक रेजिस्टेंस, दैट मींस द रेजिस्टिविटी इज इंक्रीजिंग. नीतीश निपुण को तो मुझे पता नहीं क्या करना पड़ेगा, इनविटेशन देना पड़ेगा. है
No, sir, my laptop got lagged. Just got off. Just got. Should I send it or not?
give it.
Huh?
Nothing, leave it. Okay, so out of these, which one is the having the least? So Ag is very less. Then the specific resistance is increasing in the copper, then aluminium, and then iron. Okay, so like this, the specific resistance is increasing. So why we are not using silver? Although it's a very good conductor, why we are not using silver?
Costly है.
Because it's costly. Yes. Okay. If I just put the wire of the silver, then everyone will just steal it out from the road. Okay. Now next one is, second one is the resistance wire. What happens with the resistance wire? These resistance wire already have some high resistance. Okay. These wire already have high resistance and their resistance almost does not change due to change in temperature. Just remember it, change in temperature. ठीक है. एग्जाम्पल.
रेजिस्टेंस चेंज नहीं होगी तो फिर रेजिस्टिविटी भी इनकी चेंज नहीं होगी.
आवाज तेज. हाँ, तो रेजिस्टिविटी बिल्कुल होगी ना इनकी.
ठीक है.
दैट्स
टेम्परेचर पे भी चेंज नहीं होगी.
हाँ, यस. ऑलमोस्ट डज नॉट चेंज, ऑलमोस्ट बोल रहा है वो. ऑलमोस्ट यानी कि ज्यादातर वो चेंज नहीं होती है. दैट्स व्हाई इट्स बीन यूज्ड फॉर मेकिंग फ्यूजेस एंड ऑल. फ्यूज वायर वगैरह बनाने में भी काम में आते हैं, फिर आपके हीटिंग एलिमेंट्स बनाने में भी काम में आते हैं. तो हर किसी का अपना एलॉय है. तो ये मोस्टली मेड होते हैं, दे मेड अप ऑफ alloy. टू और मोर मेटल्स और वन मेटल वन नॉन मेटल को ऐड करके जो बनाया जाता है, दैट इज द alloy. Okay, so
Yes, sir.
examples are manganese, constantan. Okay, like this. Now what happened with these have the high specific resistance. They have the high specific resistance. Okay, see, the resistivity is more na. So they have high specific resistance. ठीक है?
Yes,
And
sir.
and effect of change in temperature is negligible. Okay, negligible. ठीक है? Then third one, fuse wire. Third one is fuse wire. Now what has been done to make a fuse wire? First one is we have taken for the resistance wire. Resistance wire is for heating elements. For heating elements. Now we will be talking about the fuse wire. So fuse wire is been made how? So for this it's been made up of alloy. Okay, it's made up of alloy of this, you need to remember, okay, of lead, that is Pb, and tin. What is the symbol for tin?
SN.
Sn, yes. Okay, Sn, tin. Okay, why we made from the lead and tin? When you combine two material like lead, take some properties of the lead, tin, mixes together, you got the very different property, and that is because its melting point is low, and that is only required. I'll just explain क्यों. Melting point is low and its specific resistance is more than copper or aluminium. Okay, getting it?
Yes, sir.
है ना everyone?
Yes,
Yes,
sir.
sir.
So that resistance of short wire, short and thin fuse wire is high, okay, is high. Clear? To
Yes,
the
sir.
extent that it permits current up to its safe limit to pass through it. Okay, now what it's saying, it's saying, wait, see, this is suppose the evacuated chamber or the glass chamber, okay, having the metallic connectivity here, metallic here, and some it's of glass. Okay, now here is the inside, we have the this fuse wire. Okay, now inside we have the fuse wire. Okay, clear?
Yes, sir.
है ना? Now what will happen with this in the fuse wire? If suppose you required a very controlled amount of current, okay, and sometimes what happened, there is a appliance which is a very costly appliance is there, okay, like suppose a very costly OLED TV you have bought and it is very costly. Okay, so what we have done, we put it some resistance wire in it. Okay, now it will limit the current. Suppose if it required only the within inside the 5 ampere only, more than 5 ampere will burn the circuit of it. Okay, so what we have done, we have put it some alloy wire, with not alloy wire, fuse wire here. Okay, now when the current pass through it, so when it is going 4.55, it is around, it is okay, nothing is happening. But when there is, and its rating is 5 ampere only. Why its rating is been done? So it's been made by, it's been manufactured like this, so that its rating, it can withstand the 5 ampere of current. Now if suppose the 6 or 7 ampere of current flows through it, so what will happen when the current flows, that what happen, then the temperature increases, na? Yes or no?
Yes, sir.
When excess amount of current flows from this wire, whose can only withstand 5 ampere of current only, then what will happen, this excess current will increase, the temperature will increase. And although we have made this as a having the high resistance so that it can control the flow of the electrons, so that the TV won't get the lots of amount of current at a time, but then also we are having a very less melting point. Why? Because if certainly the temperature starts to increase, it cannot withstand that temperature and it just break itself. It just break itself. Okay, when the temperature increases due to the excess current, then its rating value, getting my point? रेटिंग वैल्यू से ज्यादा अगर करंट फ्यूज वायर में से फ्लो होगा, देन वो मेल्ट होकर अपना जो वायर है वो ब्रेक कर देगा. नाउ व्हाट विल हैपन बिकॉज ऑफ विच योर सर्किट स्टॉप, your TV, which is TV or whatever the appliance you have been connected or costly one, it just been saved from getting damaged. Okay,
Yes, sir.
so it is a protective device, it is a protective device and it's used in the series, it is used in the series connection. Okay,
Yes, sir.
any doubt anyone?
No,
Pakka?
sir.
Yes, sir. Yes, sir.
Now coming to the next one is the filament bulb. Next one is the filament bulb of an electric bulb. Filament of an electric bulb. So see which wire we widely use tungsten. We use tungsten wire because of its high melting point. Now it has the high melting point because when the lots of current is passed through it, so what happen, its temperature starts to increase, due to which it becomes red hot and starts to glow in the vacuated chamber, that is a bulb casing. Okay, glass casing. Okay, so it won't get oxidized and it won't get break it down. That's why we have covered it with the glass chamber. Okay, so what happened when it's turned into red hot, then its temperature increases. So these wire, this tungsten, this alloy wire, it's been so not actually, it's not an alloy, it shows the property of the alloy. So tungsten has the property, it has very high melting point. So when you pass the current from it and becomes red hot, it won't get melted because its melting point is high and it do not break down. Getting it?
Yes, sir.
Everyone got it? This one is easy. Then the fifth one is
Yes, sir.
the heating element in appliances such as heater, toaster, oven, geyser, etc. Okay, so for this also we use a very specialized wire because these all the appliances are give more heat. Okay, they are using for that, it's a effect of electric current, that means electric heating effect of electric current. It is a heating effect of electric current. See, the electric current has three effects. Told you in the starting, na? It has three effects. First, chemical effect of electric current, which has been done in the form of electroplating and electrolysis and all. Then magnetic effect of electric current, which you are going to learn after this chapter. And heating effect of electric current, which you are going to learn in the C1 part. Okay. So where we have the formula H equals to I square RT. Okay. This is the heat equals to I square RT. This we are going to learn in the upcoming classes. Okay, so why it's been made from the, so it has the specialized wire that is of nichrome wire, that is a nichrome wire. You must have heard of it. Nichrome wire
Yes, sir.
is used.
Yes, sir.
Why nichrome wire is used? Because its resistivity, that is specific resistance is high and its resistance increases to great extent with rise in temperature. So you must have seen when you just turn on the heater or something, at the starting its temperature is little bit low, yes, and when with the time it starts to give more heat, yes or no? Well, it will not like it keeps on increasing, yeah, but it just increases to some extent. Why this happens? Because see, in the starting when the current starts to flow from the wire of the nichrome, so what will happen, it will resist the flow of the electron and starts to heat up red hot glow. Okay, now when the temperature increases, so now this heating up is because of the specific resistance of the wire and the resistance also. But when this current is increasing, so its resistance and specific resistance also increasing according to it. So it will block more amount of current. It will block more amount of current. So more blockage means more heat it will produce. Okay, getting my point?
Yes, sir.
Hmm.
तो माइक्रो होता है उसमें तो, लेकिन माइक्रोवेव से
Yes.
गर्म हीट आती है ना।
What?
माइक्रोवेव जो होता है उसमें तो
हाँ,
माइक्रोवेव जो होता है
माइक्रोवेव यूज द रेडिएशंस, इलेक्ट्रिक स्पेक्ट्रम में
हाँ
पढ़ा था
वही
ना।
मैं कह रही थी।
It
हाँ
has a
वही मैं
power,
कह रही
हाँ,
थी।
it has the power transformer which is used for emitting out the microwaves. It do not have this.
मतलब
हाँ, if
उन
instead of
माइक्रोवेव के लिए भी वो
oven is
इलेक्ट्रिसिटी यूज
there,
करते हैं।
you have seen that oven is there, like patties one oven देता है ना, patties वाला जो रहता है उसमें,
हाँ
so
हाँ
one
हाँ
is the gas one they have and some of them have the this electric one also. ठीक है?
हाँ हाँ।
उसमें. Now the last topic is the superconductor. So this already I told you. What is superconductor? Anyone?
Something with a very low resistance or negligible types of resistance, very high conductivity.
Yes. ठीक है.
But
So
at a very low temperature.
हाँ, at a very cool temperature. That is yes. So let's first of all write a superconductor is a substance of zero resistance,
पर प्रैक्टिकली जीरो रेजिस्टेंस तो पॉसिबल नहीं है ना।
almost पहुंच जाता है, almost,
इसलिए
or we can say zero resistance means infinite conductance, infinite conductance at a very low temperature. Now see this relation of this one. It's saying of zero resistance. If rho is 0, then conductance will be, sorry, it's a resistance, na? Just a second. Not specific, that is the resistance. So R is 0. So it's about asking for the conductance. So we know G is equals to 1 upon R. So it becomes 1 upon 0. 1 upon 0 is infinite. Okay, so G is infinite. Got it?
Yes, sir.
Everyone? Okay. Now, let us write the what is happening in this. So, it is been observed that resistance of some substance like tin, lead, etc. Not copper and all. Okay, there must be some resistance in it because it's have the resistivity already. Okay, so like tin, lead, okay, decreases tremendously with decrease in temperature, and becomes almost zero. Okay, almost zero. Now such substance or material we can say are called superconductor. भाई अच्छा एक चीज बताओ, सुपरमैन कौन है? हु इज सुपरमैन? जिसके पास काफी सारी चीजें हैं, although he is a man but he is a having lots of amount of energy we can say, or very it's good at everything. He is good at everything. Yes or no?
Yes, sir.
सिर्फ एक चीज को छोड़ के, क्रिप्टोनियन को छोड़ के, बाकी नथिंग कैन डिस्ट्रॉय हिम. In the whole Marvel and DC movie, the only one man who is very strong is the Superman. And the next, if I talk about the man, that is the Batman. Because Batman do not have his own power. Like Batman is there, he do not have any his own power. He made himself like that only, superheroes one. Getting my point? Although he is very rich, Bruce Wayne is very rich, but लेकिन that then also Superman का नाम Superman क्यों पड़ा? Because he is super in everything. Although he's a man, but he's super. Like conductor. Why superconductor? It's a conductor because it will conduct electricity. Why it is super? Because it has almost zero resistance in it. So whatever the thing which brings the hindrance in the path of the current, we can say, or in the path of the man's, in the man and woman life, like in the humans. So that's why that has been removed. So it becomes superwoman or superconductors. Getting my point?
Yes, sir.
So these superconductor have infinite conductance. Okay.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Now what happened in this, why this is so much good? Because there's a condition. Then why it's been superconductor, infinite conductance? Because once a current starts flowing in a superconductor, it persists even when there is no potential difference across it. Okay, now you can just relate it with the Newton's law. Why? How the Newton's law? The Newton's first law said, if a body is in motion or in a state of rest, it will remain in its state until unless some external unbalanced force act on it. Yes or no?
Yes,
This
sir.
was the Newton's first law.
Ah.
So why this, and why it is not applicable on Earth? Like if we have to take the vacuum chamber for that first law to be applicable. Okay, it's not applicable on Earth because there are lots of external forces which has been acting, like frictional force and everything. Okay.
Yes, sir.
Similarly, in the flow of the path of the current, the what main thing is been acting here is the resistance, which do not let the current to flow with the its own speed. Yes or no? So
Yes, sir.
if you just remove that hindrance part or that obstacle part from the path of the current, so it will keeps on moving. Once it is been moving, it will keeps on moving. Getting my point?
Yes, sir.
So that is the what it is. And once the current starts flowing in the superconductor, it persists even when there is no potential difference across it. Got it, everyone?
Yes,
I
sir.
got it.
Now here are the some examples which we use to take the superconductors are. Okay, it's been given like mercury below 4.2 Kelvin, lead below 7.25 Kelvin, niobium below 9.2 Kelvin. Okay, so it's not like कि हम कॉपर को ठंडा कर दें, बर्फ में रख दें और फिर करें ना. ठीक है? There are the different materials which is been used as a superconductors. Okay, so these all are the superconductors. Now why these we cannot use in the wirings and all? What is the reason?
मरकरी का तो मेल्टिंग पॉइंट मतलब नॉर्मल टेम्परेचर में मेल्ट हो जाता है.
Temperature cannot be kept constant.
हाँ,
Yes.
temperature not constant. It is very difficult to achieve that temperature.
Hmm.
And that is the reason that we are having the MRI machine, that is magnetic resonance imaging machines. They use the same technique of superconductors. Okay.
Yes, sir.
Getting my point? So the thing is,
Yes,
for
sir.
doing this, we require a very low temperature, which is not possible. हाँ, once you get if the scientists and the researcher engineers got the idea to make them behave as a superconductor at room temperature, then so everything will be very small, then very compact in size, very very compact. Okay, getting my point?
Yes, sir.
So till here we have finished this one first A part. So go through all the videos which has already been uploaded. ठीक है, ये नोट्स वगैरह है ना, ये चाहिए हो तो फिर मतलब है तुम लोगों के पास तो ठीक है, बाकी यूट्यूब पे डल रहे हैं तो जिसको चाहिए हो दैट्स पुट इन द मैसेज, ठीक है। और बाकी ठीक है, इसको कर लेते हैं, फिर क्वेश्चंस वगैरह को आज करोगे या बाद में, या फिर वर्क एनर्जी बताऊं?
तो मर्जी आपकी।
So today, tomorrow we have class.